MS Ramaya University of Applied Sciences.
Hi students, let us discuss about profile projector. The aim of the experiment is to use optical profile projector to measure geometric dimensions listed below: angles, distance, depth and diameter. Definitions. A profile projector is an optical measurement tool that magnifies a sample surface features to allow measurement on a linear or circular scale. A profile projector is also referred to as an optical comparator or even known as a shadow graph. A profile projector projects a magnified profile image of an area or feature of a workpiece onto a screen. Dimensions can be measured directly on the screen or compared to a standard reference at the correct magnification. Principle of measurement. The device works on the principles of shadow and reflection. At first, light beam originating from the lamp is condensed by condensing lens and falls on the workpiece. The image of the workpiece is carried by the light beams which passes through a projector lens. The projector lens magnifies the image which falls on the highly polished mirror kept at an angle. The reflected light beam carrying the image workpiece reflected on a transparent graduated screen. Procedure. Clean the workpiece to be measured. Switch on the profile projector. Place the workpiece on the table. Focus the workpiece and get the magnified image. Measure the desired dimension and interpret. Measurement using profile projector. The advantage of profile projector is their ability to measure in two-dimension space. Unlike micrometers and calipers, which measure one dimension at a time, comparators measure length and width simultaneously. To do this, the operator lines up the lower left-hand corner of the image with the screen center line to establish a 0 point as illustrated above, and then checks the upper right-hand corner to get a simultaneous reading of both length and width. The straight line distance from corner to corner can be obtained with a single keystroke. Using chart gauges for go or no-go gauging. Standard chart gauges such as tool room charts or custom chart gauges with minimum and maximum tolerance zones can be used as go or no-go gauges for quick inspection. In fact, using chart gauges this way on an optical comparator is still one of the fastest and most cost-effective methods of measuring profile dimensions. Measurement by screen rotation. Angles can be measured by moving the crosshairs of project screen. The projector screen crosshair is aligned to one of the edge and initial reading is recorded. Then the screen crosshair is rotated and made aligned with the other edge, and the angle between the edges is computed as the difference between the initial and final angle reading. We are having a digital readout attachment called QM data that will automatically compute the angle.
Hello students, the name of the experiment is measurements using profile projector. The aim of the experiment is to measure different profile characteristics like angle, distance, diameter and center to center distance using profile projector. A profile projector is an optical measurement tool that magnifies a sample surface features to allow measurements on a linear or a circular scale. A profile projector is also referred as an optical comparator or even a shadow graph. A profile projector projects a magnified profile image on an area or a feature of a workpiece onto a screen. Dimensions can be measured directly on the screen or compared to a standard reference at the correct magnification. The different parts of a profile projector are the projector screen. The profile projector screen has two lines, the x-axis line and the y-axis line. The both lines meet to form a crosshair. This crosshair helps us to pinpoint the coordinates on the profile projected image. The angles can be obtained by rotating the angle screw. This angle screw rotation can be locked by using this clamp nut. Here one can see the x-axis moment and the y-axis moment. On the left side you can see we can measure the angles. There are two modes. One is the absolute mode, other thing is the incremental mode. The projector head. This is reflector illumination lamp. The rating of the lamp is 24 volts and 150 watts and the life of this lamp is for 500 hours. The projection lens, XY stage. This is the XY stage. This is the y-axis. This is the x-axis. The y-axis movement can be measured by looking at the digital readout. The least count is 1 micrometer. Similarly, the x-axis movement can be monitored by seeing the digital readout. Moving both x and y will get us the coordinate points on the projected image. Here one can find the contour illumination lamp. This is the contour illumination lamp. The life of this lamp is for 500 hours and the rating is 24 volts and 150 watts. The focusing wheel. This is the focusing wheel used to raise the XY stage. And switches for operating the illumination lamp. The first switch is used to operate the contour illumination lamp. The second switch is the brightness selector for the projector screen. The third switch is used for reflector illumination lamp. And the QM data. Now let us start the experiment using the profile projector. Before starting the experiment, the first thing one has to do is to clean the XY stage glass using a soft tissue and then remove the projector lens cap. The next stage is to switch on the main switch. Now switch on the contour illumination lamp and see that you are getting a light on the projector screen. Today we are using a training template as a profile. Other manufactured parts can also be used to measure the features. Now place the component on the XY glass. Next step is to use the focus wheel to get a clear image on the projector screen. Now, before switching on the QM data, make sure you are having a reading on the y-axis counter and the x-axis counter. If you are not having a reading, just have a gentle rotation on the left or the right and make sure your XY counters are reading. The next step is to switch on the QM data digital readout unit. Now you can see the X coordinate, Y coordinate on the QM screen. These are different buttons and options one can select to find out the measurements on the screen. Now let us measure the diameter of a given circle. So I am going to choose the circle option from the QM data. The QM data is asking for 3 points or the 3 coordinates of the circle, from which it will compute the diameter of the circle. The first point, the second point and the third point. So let us find out the diameter of this bigger circle. We need 3 points or 3 coordinates to find out the diameter of this circle. So let us choose the first point by moving the X and Y axis. I have chosen the first point and then I am loading this first point coordinate to the QM data. So this is my first point. I am selecting the second point and I am loading the second point. The last or the third point now we can find out the diameter D, which is 3.969 mm. So this is the diameter of the bigger circle. It is 3.969 mm. 3.969 mm. The radius is 1.985 mm. Now other features one can easily measure using QM data are the line, the distance, the rectangular hole, the slot dimensions, angle, distance between two circles, line, point, midpoint, point to point midpoint, perpendicularity, parallelism, the radius and other options as one can see. One can get the printout of the reading and one can generate the inspection report after the measurement. Before ending the experiment, let us not forget how to switch off the machine. The first thing which you should switch off is the QM data. Before switching off, ensure that the QM data is in the home screen position. So you can use the cancel button and come back to the home screen position and switch off the QM data. Switch off the contour illumination lamp or the stage lamp. Close the projector lens using the projector lens cap. and switch off the main power switch. Now this stage ends the experiment, the measurement using profile projector.
At MSR UAS, we spark your imagination unlike any other.